welcome everyone to our session. I named it as the Expanded Middle, and because ESIP started as a group that primarily focused on the data from federal agencies. And in the past few years, we had a lot of conversation about who's using those data. And one of the conversation, we see that there's actually a large group that is increasingly using the data from those federal agencies like NOAA, NASA, USGS, and other, and but it's not necessarily in the discussion or the community of ESIP. So I believe maybe 2 or 3 years ago, there was an ESIP lab project or Funding Friday project supporting connecting with the local and state government who are using those Earth data for decision making. And so in this session, we're going to have 3 examples of how different way local and state governments or a partnership with local and state government to use those data and emerging technologies to support decision-making process. And if you can, please go into the Google Notes documents that Madeline shared in the chat to provide your information for attendance in this session. And without further ado, I would like to introduce our first speaker, which is Jared Bowden, who is the interim state climatologist for the North Carolina, and also with North Carolina State Climate Office, which is part of the North Carolina State University. Jared, the floor is yours.
Thanks, Douglas. Does everything look good on your end, Douglas?
Yes.
Okay, great. I'm going to try to minimize this here. Thank you all for joining this session. And I'm going to talk particularly about the state of North Carolina and climate resilience. There is a focus and emphasis on flooding, which has been a big problem. But I want to talk about how we can support the state and local partnerships using climate scientists, your knowledge, the research we do, the data that we create and we have, and in particular thinking about product development that can support some of these partnerships. And so I can so how I said I'm going to talk about flooding and how did all this really come about. I think when we're thinking about state and local partnerships, we're really thinking about problems that they're dealing with and what they're facing. And in particular, a big problem in the state of North Carolina has been hurricanes. Tropical events have created lots of flooding issues across our state with large impacts. And so I just talk about Hurricane Matthew and Hurricane Florence. And there was, like, for instance, in Hurricane Florence, more than 30 inches of rainfall. But these hit similar places in eastern North Carolina. And on the right-hand side is the number of pipes washed away from all of this. And so it's very significant damage and costly disasters. And to be, how can, for instance, DOT be more resilient to future flooding was one thing that they were questioning. And so how did this all come about? Really, it's really driven by state priorities at first. And I'm going to talk about how state will feed into local decisions in a little bit. But it really started with Executive Order 80 for our state, where the governor basically said, hey, all state agencies need to think about being resilient to extreme events. And in particular, this really spurred DOT's interest because they were like, hey, we have to think about these events because they're very costly to us. So this is just a simple slide. And if you're not familiar with the events that have happened in terms of tropical events across our state, there's been many events. Most recently, we had Tropical Storm Chantal hit actually where I live. I live in Chapel Hill, North Carolina, which is right in the middle of where Chantal basically created lots of problems and lots of flooding and lots of local damage for communities. And so there's this need at the local level, but how do we best provide insight and information to think about, for instance, future flooding risk, which we know is a concern. And so this really starts when you're thinking about the expanding middle and being able to assist people. I think it really starts first with states and state agency concerns. And so the first thing they were thinking about was more intense storms. And so I started thinking about this and how can we really assist the state thinking about more intense storms. And if you go to the most recent, we had a North Carolina climate science report, and this is something that I'm in charge of updating for our state here this year. But it states that precipitation intensity will increase as climate warms. So what does this imply? Well, this implies a lot for instance, for infrastructure. And in particular, when you're thinking about it, they look at these things through things like design storms. And so they look at a given event and they stress test their infrastructure. But will these stressors, for instance, these design storms, change as the climate warms? And how can we assist these state partners? And even I'll talk about how it feeds into the expanding middle local to be more resilient to this increasing risk of more intense storms. And so this is this is where we started talking with them and trying to understand their need. And in particular, they said, "Hey, we need to avoid these negative outcomes. They're very costly. In particular, there's several things that are very important. And one, when you have an interstate go down for a week at the time, and this is a figure of I-95 underwater, which was underwater a week, both in Matthew and Florence. And this is a problem, and it costs our state lots of money, not only just because it creates damage to the infrastructure, but just because being able to go around these closures is very costly, for instance, for transportation and trucking of goods. And so they said, well, we're risk averse. We want to think about a high risk scenario. And so understanding some of those needs and thinking about, oh, we need to think about a high risk scenario for them, in particular, thinking about historical tropical cyclones and hurricanes. And so we took a look at that, and this is where I think climate scientists can get creative and design experiments using the tools and knowledge that we have. And so we have atmospheric models that we can use. And there's a something called the pseudo global warming methodology. But basically, you can think about future design storms, and you can think about this more intense storm of the future. And basically, what we do is we can simulate a historical event with our models. For instance, this winter event that's coming through, we can simulate that in a retrospective sense as well as forecasting. But then we can then apply changes in the environmental conditions and see how that storm responds. So, for instance, if the sea surface temperatures warm and the atmosphere warms, what does that mean for hurricanes, for instance, and how much rainfall could fall from these storms? And so we can replicate these storms in these future environmental conditions and basically produce this future design storm of the future, which is a need of the middle. And so that was a state agency need that drove this research. And so I'm not going to get into a ton of the research itself, but this is an example of this methodology applied to Matthew, Florence, and Floyd, which are three big hurricanes that created devastating flooding across eastern North Carolina. And then we can simulate, so we can look at the observed, and then we can simulate and say, hey, we do a pretty good job of simulating that event when we compare it back to observations. And then we can say, well, how would that look in the future? And that bottom panel is basically the future. And you can see, for instance, Matthew simulated precipitation totals were around 620 millimeters. But if you go to the end of century and you say this risk averse scenario, high emission scenario, it could be upwards of, more than 1150 millimeters. And so these type of storms are important because they provide a deterministic approach to think about this future storm intensity, and how we can then use these experiments to inform decisions. And so the expanding middle means that we have to take advantage of what the state and what the state agencies currently do and the resources that they have. And in particular here, this data, this future storm data, was used with contractors that worked with the Department of Transportation, and were able to run these what they call rain on grid hydrology models to then look at surface elevation increases. For instance, how high is the water, and how high does this bridge need to be? I-95 was underwater. The bridge was underwater, the road and everything. So how much higher should it be? And can we actually do anything to mitigate that based on those plausible future scenarios? And they can also look at things like future flow. And so this is just an example here. And you can clearly see in the top the increase in the water surface elevation. That gives DOT, the state agency, insight as to, based on this event, how high should this bridge be to avoid this future scenario. And so this is common, the climate resilience and thinking about adaptation. That's really important, thinking about the expanding middle. But it takes multiple partners and multiple resources because, for instance, I'm not a hydrology modeler, but it takes somebody with that skill set to be able to work with them directly and use this information. And then there's the increasing frequency of the impacts. And I quickly want to point out that, when you look at Florence and Matthew, and there was the washouts of those pipes that I talked about earlier, lots of places had washouts right when they just fixed it. And that's the increasing frequency and creates issues, for instance, for state agencies. And thinking about how to be more resilient to frequency. Well, the first approach was a more deterministic, looking at that future storm, but it can't really tell you anything about the frequency of what will happen in the future. And we know, based on, for instance, the climate science report, that it's anticipated the frequency will increase. And so what does that infer or imply? That the infrastructure will be subject to more frequent flood-related stressors. But again, this requires a probabilistic approach. And so there's lots of data available, climate change projections. There's a lot of, especially for the U.S. downscale climate model data to support things like looking at frequency changes. And this is just taking a look, for instance, out west in Haywood County, where DOT also had a bridge failure, and it's looking at the future. And so what you're really seeing is future rainfall in those box and whiskers plots. And then you're looking at what we call, these are basically like your 100-year storm. So in 24 hours, how much rainfall falls to be classified as a 100-year storm. And so on the right-hand side, you'll see that there's these 10, 25, 50, 100, 500, 1,000. Those horizontal lines are what they currently designed to in terms of rainfall depth. And if you were to think about, what the plausible future would hold, for instance, at end century, this high risk scenario, you'll clearly see, well, the 500 intersects a 100-year event of the future. So there's clearly, the models are indicating large frequency changes in the future. And so can we do anything to support that? And so we took all of this information and created this tool called Raindrop for North Carolina. So this gets into not only the data that we can create, but thinking about the products that can come from the data using different types of unique analysis. And so I just put this QR code here, but it's called, we called it Rainfall Intensity Duration and Return for Observations and Projections. And so I quickly want to just kind of show you what this tool does. It's very similar to what engineers use. And so we basically said, hey, we want to try to mimic that as much as possible and to make it user friendly for the engineers and the contractors, so then they can make decisions based on future rainfall changes. And so on the top would be, for instance, for 24 hours, what would the rainfall, how much rainfall would fall if you considered looking at the probability and you think it's a 100-year storm. And and so you can point and click and get a grid point estimate of what that would be. But then on the bottom, you can then basically choose a scenario, a future scenario. And so there's a bunch of different future scenarios. But what I wanted to point out here is I simply chose the same thing, but then I changed the return period to 50 years. And you'll clearly see even the 50-year, if you look at that grid point, exceeds what currently is considered a 100-year. So there's definitely changes in the frequency that you can clearly illustrate here. But we also provided this ability to toggle on values and being able to point it, for instance, put in a latitude and longitude you want. And this is what the middle wants. The middle wants this information. This is the engineers. These are the people that are designing our highways and our infrastructure. And NOAA Atlas 15 is working on this. So this is something that NOAA is working to create, but it's really important, and it's being used. And I'm going to show you why this is really important, because Atlas 15 is going to become available for the contiguous U.S. Within probably this upcoming year. And so I want to illustrate applications, how the middle may actually think about using this information. So there's data layers behind this tool. And so you can take these data layers and then put it into the same people that did the hydrology modeling can then put it into other models. In particular, this data set that we created with this tool is supporting DEQ, and this is something called the North Carolina Flood Resiliency Blueprint. And so basically, they're running these 2D rain on grid hydrology models across our state for different basins, and then taking these different scenarios, including future scenarios at different time periods, and being able to basically see what the frequency changes look like in terms of flow. And so I just want to show you like something from the blueprint. So this data is being used within the blueprint. And this is an example of this rain on grid hydrology modeling being used. And so the first thing you see is the blue. So this is the 100-year storm. This is the flooding extent based on a 100-year storm. This is a regulatory floodplain. Well, then they run these rain on grid models with the observations, basically, rainfall depths that would be a 100-year storm. And they say, hey, actually, if you look at that expands rather significantly just using the change in methodology in itself. But then on top of that, if you think about these new future scenarios, and this is just an example, you can see that expands even further, right? Places that haven't seen flooding could possibly see more flooding, and communities can think about what what the implications are for planning purposes and thinking about being more resilient. I also want to mention that, once you do this, that other things start just growing in the middle, and it's almost kind of natural how this has happened. And so once people become more aware of what you've created and you've done outreach about it, they start using it. And in particular, there's I-40 washed out after Helene in Western North Carolina, and they wanted stress tests, or wanted to look at basically what a future storm might look like. And they took all of this information from this tool and then run these different rain on grid hydrology modeling scenarios to then say, actually Helene was considered a 1,000-year storm. And you can, what you're looking at is basically some of the flow on the right-hand side, and I kind of highlighted. And basically, you can see large increases if you consider what might happen at end century. If you think it's a 1,000-year event, it's much, much larger. And so, but this is helping to support Helene rebuilding efforts in that expanding middle. But I think the more important thing to kind of illustrate is what happens, I think, at the state level eventually filters down to the local level. And in particular, I started thinking about what this means. And this is two examples of two municipalities that are currently taking, for instance, some of the stuff that we've developed and the data that we have, and being able to then implement it for decisions. And so there's simple things that happen. For instance, basically, some of the decisions, like if you want to update your stormwater design standards, for instance, Knightdale is using a 100-year event where DOT is using a 50-year event, and they justify things like changing these design standards, same as Fayetteville, using the data that we created. But also, then they take it a step further, and then they think about, well, what if you're working with this data set and then actually using it and implementing it? And currently, for instance, I said this expanding middle. This expanding middle includes the technical people that can actually do some of the things that the communities want. And for instance, in Knightdale, ESPE, which is a contractor, ESP Associates, is using this data set for a watershed assessment. And so they're like, we want to know, well, what is possible in the future, because we've had really extreme rainfall events, and it's costing our town a lot of money. And the same thing was used in Fayetteville. Actually, was used in the design phase of a large capital improvement project to evaluate the level of service of that project. They don't want it to go down. They want their services to make it through these extreme events and being more resilient to the climate and climate change. And I want to mention that it's important to continue outreach for decisions. And this is just something that I'm working on is American Public Works Association, and I'm working to give a click, listen, and learn series about this tool and thinking about embodying long-term flood resilience. And so I'm going to end with this slide and thinking about the expanding middle. And I think the expanding middle is really somewhat thinking about those people that are technical skill people, for instance, the contractors that can then support what decisions actually they need to make, for instance, the town of Knightdale and town of Fayetteville. But it's also a filtering of state priorities down to community level that basically once a state started adopting some things and looking at it that way, then others kind of took and said, oh, actually, that contractor has experience with that now. They did it for the state. We can use it for local level decisions. And so I just put a simple formula here of thinking about how, for instance, some of the data sets that we have can then be combined with what others have to support the expanding middle and the needs of state and local level. So thanks, Douglas, for inviting me to the session. Hopefully you all found it helpful.
Thanks, Jared. This is great. And we will hold the questions until the end of the session. And with that, I'm going to turn it over. I have to admit, we have a North Carolina bias for this session. Jared is the current state climatologist. And then next speaker, Jim Albuquerque, is from the city of Raleigh, which is state capital of North Carolina. And our final speaker, Dev, used to be the state climatologist in North Carolina. So I just want to state all the bias that we have for this session, but we are looking forward to working with other city and state officials as well. Jim, the floor is yours.
Awesome. Can you verify you can see my screen, my slides?
Yes.
Awesome. Great job, Jared. I think it kind of dovetails nicely with what I wanted to talk about, which is just how cities like Raleigh are using sensor data, national data, and other data to help provide situational awareness and data products for our staff to better understand what's happening in our city. So for those of you who don't know anything about Raleigh, North Carolina, we're 500,000 people. As Douglas mentioned, we're the capital city. Just to right size us, 4,000 employees. Here's our budget and fairly large land area, so not super dense. One of the phenomenons that's happening in Raleigh is it's one of the fastest growing areas in the country. What that population pressure adds is we need to figure out how to continue to deliver these services to our citizens that are desirable and that were the reason that some of these folks are moving. I think relevant now is how do we keep some of those people safe, and how do we deal with events that are happening in our city. So we've dealt with in data for a long time. I think we're fairly mature in thinking about data, and I'm a GIS guy, so I think very much about geospatial data. And we're using geospatial data in all sorts of verticals around operations and strategy and storytelling. One thing I wanted to kind of double click on, given our current situation, is just our emergency operations. So I think this is relevant. Obviously, we're trying to aggregate data from hyper local sources, but also kind of supplement that with data provided from national organizations and state organizations, like Jared was mentioning. We use the FIMANS tool, which is a flood monitoring application frequently. We also plug into the NOAA stream gauges to monitor our streams and the rising levels related to hurricanes, et cetera. We also track, obviously, real-time information around how our assets are operating, where citizens are reporting issues, and our response to the event. This is a product that we're working on, a community conditions model, which is trying to understand how people are experiencing a number of different verticals. And a way for us to target investment, make sure that we're equitably engaging with a number of folks around the community, measuring outcomes, those sorts of things. These indexes that you're seeing on the screen, we have a transportation index, an environmental index, housing, et cetera. So these are some of the sub-indexes and metrics and data sources that we're using, include things like data published from the EPA around particulate matter, and other national data sets that participate in some of these indexes. So, I'm pretty passionate about thinking about advanced modeling and can we use kind of the latest and greatest technology to better understand our very complex world. And we have kind of been dipping our toe in this for a long time and trying to see what the capabilities of the technology are. And as I mentioned earlier, we are one of the fastest growing cities. So just early work was, can we just understand what our city looks like? We have lots of conversations within the city about people's concerns around what this impact of development will be. Can we base that in data and visualizations and make sure that we're grounded in real information? So again, early work, just trying to understand the capabilities using things like how will development affect my access to sunlight, et cetera. So next is to understand what the city will look like tomorrow. We think we have a decent understanding of what the city looks like today. Can we start to understand what the city looks like tomorrow, just from an urban design and visualization perspective? And so what you're seeing now is a development that's happening. And so we incorporated some of the design drawings, but then we can also theoretically start to incorporate real-time data or near real-time data around progress of construction and the actual physical environment and the urban form. We were one of the CAPA cities, the Raleigh-Durham area, so we were able to do a little bit of data collection in, I believe it was 2023, around heat island and how people were experiencing heat. And so this has been useful in understanding how people are experiencing heat and mitigating those extreme temperatures with things that the city has control over. So there aren't a ton of things that the city has control over, but when we think about resiliency hubs and cooling centers and other opportunities, we use this data frequently. But if we can incorporate it into a digital twin, in this case, it helps us on the engagement and the storytelling side. So this is much more of a different way to engage with this data and allow and share the data kind of more broadly for usage. An interesting project that we had an opportunity to work on was with MITRE around microclimate modeling. So this was leveraging I'm kind of punching above my weight a little bit here, but leveraging a Joules model, which is a physics-based atmospheric modeling kind of engine. And one of the inputs that, again, makes this a good fit for Raleigh is it can take the built environment and incorporate that to model wind and ventilation corridors. And obviously those things affect how people experience heat in a city like Raleigh. And so this gives us some ability to do some scenario planning around what does a day in 2027 look like with a southeasterly wind, with ambient temperature of 108 degrees, and how do people in various neighborhoods and potentially even street by street, how do they experience it? And then what happens if a particular development happens in a particular area? How will that affect how people experience heat and climate? I keep kind of harping on the idea of modeling. So this is, as developments kind of get submitted for review, or there starts to be permits issued, can we start to model the downstream effects of what these developments the impact they will have on the city? In this case, it is what is the impact to traffic and greenhouse gases based on land use, proposed land use. So working in a digital twin environment in a city that's pretty dynamic, keeping that digital twin up to date is actually a fairly significant amount of effort. And so we're starting to look at other technologies to allow us to start to try and keep our finger on the pulse of the existing conditions of the city, including capturing digital models from drones and developers, et cetera. And so this, just using this technology, we're able to start to model the built environment, again, in near real time. There's some logistics that we need to work through about how we staff it and what's reasonable, but we've had some reasonable success in this area. So the last thing I wanted to talk about is just this idea that there's the instrumentation of our city. So if you work in cities and you have assets, that you can't buy an asset anymore that isn't instrumented with some sort of a sensor. And one of my jobs is to try and make sense of that data and present it to decision makers and leadership to be able to leverage that data to make decisions, to whether they be tactical decisions on the operations of the city, or strategic decisions about the general direction of the city. And this is happening in every city in the country. And it is just access to data is no longer our key issue, right? Obviously there are gaps in data, but we have so much data available to us that now it becomes how do you create information products and analysis for decision makers? And a project that we're excited about is starting to leverage cameras as some of these sensors. So can we use cameras to start to derive data from that and then incorporate that data into models? And so our current pilot is around doing computer vision related to vehicles, pedestrians, and bikes. We've had good success in modeling intersections. And this is going to give us much better visibility into tactical signal timings and trying to be more efficient in modeling the city, et cetera. But I think relevant for this conversation is that as we kind of start to show this to our operations folks, a great conversations start about like, oh, well, what other things does the camera see that might be relevant? There's the obvious stuff around asset condition and cleanliness and those sorts of things. But our stormwater folks are like, hey, can we start to measure volume and flow of water if we start to experience flooding events in real time? And quantify that. So that's something that we're really excited about. We think this is going to be kind of revolutionary to how we collect and monitor data in the city. And so, yeah, again, we're really excited about that. Yeah, that's it. I really appreciate your time. And yeah, as Douglas mentioned, hope everyone stays safe from the weather event that's happening.
Thank you, Jim. This is awesome. Yeah, a lot of innovation happening at the city. Mark, do you have your hand raised?
No, sorry, that was a mistake.
Okay. I was like, did I miss any instruction from the staff? Our final speaker is Deb Nielke from University of Texas, Austin, and who is also the UNESCO chair in Open Data AI and Water for Cities. So I met Deb through, a few years ago, we were on NOAA AI workshop, and now we started the NSF workshop proposal together on digital twins for the cities and atmospheric sciences. And so I think Jim's presentation lined up quite well of the things that Deb is excited about. And so Deb, this floor is yours. You're muted right now, so.
Thank you very much. I really enjoyed this session and learned quite a bit. So it's a pleasure to continue sharing some of the ideas that are underway, which are somewhat similar to what is being going on in the context of work that is being done through city of Raleigh and few other cities. And as Doug mentioned, we have been consolidating and coordinating the digital twin for cities framework through the WCRP, WMO Digital Earth Initiative, because we have mostly global scale work going on, and then putting it into a smaller scale for cities has been really interesting to see how do we bring in those scales, because that is where the decisions occur, as you saw. So I would actually love to follow up with you, Jim, and others on the work that is being done. So I would like to acknowledge my presentation co-leads, Zach Baumer and Mark Kuder, who are with the City of Austin and part of the CoLab co-leadership that we have, and Bhanu Nepane, who is the coordinator from UNESCO as part of the UNESCO chair, where we are taking some of the knowledge gained here to global partners, and from global partners, what is going on in other parts of the world to the research enterprise here. This builds on some of the similar themes that have emerged. We have, of course, in Texas right now, we are staring down the barrel, so to say, at a ice storm that is emerging. We don't know whether this will be a major ice freeze event or a rain snow event. Whatever it may be, it is very clear that we are looking at some recurring, unusual weather that places like Texas have not been used to. We have seen hurricanes, we have seen heat waves. As Doug mentioned, when I was in North Carolina as one of the state climatologists there, we had Hurricane Fran and Floyd. And so hurricanes have been something the South has been used to. But ice and the impact that follow has not been something that has come up. Wildfires have something that also been on the vision, because very often the conversation goes down to it is not when, if, it's more about when it will occur and what do we do about it and so forth. So what kind of data is needed and so forth. So if you look at it in the context of where this kind of a middle partnership or collabs, as we call it, city collabs come up, is from the context of a city like Austin, there are several questions that come up. I mean, Jim showed in a wonderful way for what is being done for Raleigh, whether it is for mobility development, alignment of different goals, council having one need, the city managers having one need, the engineers having other requirements, the kind Jared showed. Consultants are great, but they're also expensive sometimes, is what the city has found, and the engagement could be more like of a what you call I think the parachuting, doing a problem going, and there is lack of a knowledge base that starts growing locally. That has been one of the problem, and the relationships that need to be developed with researchers to develop long-term innovations, because if you start with a problem, you do something, I think there's a long tail that can emerge from there. And there could also be a talent of students going and working, was one of the aspects that the city thought that when you have a town-gown partnership, like the one we have with academia and a university and a city all put together, the community can actually benefit from that. From the UT side or the academia side, the benefit is that we look at more and more applied research. I mean, it is always fascinating and nice to do your work, which is science-based, published, it is peer-reviewed, and it is not just a put on a blog, but it has been really tested through the gold standard that we use in science, which is peer review, and peer review from a good standard professional journal, not some of the MDPI kind of journals that come up here and there nowadays. So strong professional review, strong scientific foundation, and then bringing it up has always been the first step. But it is increasingly recognized that we can't stop there. There is an interest that we need to do things that what then? That taking this science, how can it be applied as a research tool, the kind that we have seen? And that has becoming a lot of core of many of the projects that are going on. It has also been a part of the federal grant requirements. And so there was a confluence of many ideas. The idea was that can we leverage these kind of partnerships that go on between the city, that can go on with the community, that can go on with the academia, from taking the science to application or a prototype to a product mode, and then unlock some more research support, funding support that can develop some tools that help everyone. And frankly, this is what I think students are getting more and more interested in as we are getting into an AI-driven world of where we are. So that created the UT City Collab, so to say, which connects faculty, municipal staff, community groups. And the initial goal has been that we create city-centric tools, data information, data products, and assessment. A lot of what we have been doing with Climate Perspective thus far has been, if you saw Jared's presentation, he used that term pseudo-global warming, which has been the typical way. You start from the global models, you look at the global scenarios, and then you try to downscale it down to the region of interest, a city of interest, and so forth. And if you saw Jim's presentation, that was really on the other extreme, where you're really going from a street, you're going from a building, you're going from a context where, how do I want to change things? And then you're trying to develop that information into a macro scale. So when you look at cities and the kind of information they need, they don't only need the downscaling, they also need that upscaling. And so how do you create this kind of a partnership where you have the upscale knowledge and downscale knowledge put together, where we can then start finding out how do you create digital twins or how do you create these decision tools? That has been one of the core aspects from the science to engineering perspective for this science collab that we have been doing. So the initial projects that we have been doing were regarding with climate projections, very similar to what happens to Raleigh or other places, what it means for Austin, given the global context, what are some of the things so that we are placing the problem into a global context and what it means for the cities. And one aspect we have been highlighting is that, yes, there is, of course, an increase in temperature, but we are also highlighting the manner in which we are getting the swings in the temperature. First, Second, we are also highlighting that we are getting locked into weather patterns. So when we are wet, we are locked for the wet pattern for a while. When we are in a cold, they will be less frequent, but when we do get them, they are going to be much more severe. They are going to be longer duration and are going to have a longer impact. And unfortunately, that is what we are seeing right now with the storm. And clearly, the cities across Texas and other places in the South are doing everything that is humanly and technologically possible. And we are just keeping our fingers crossed that everything goes well. But not having good science that is already available as a part of a solution is not acceptable to anyone. And this is where I think some of the work and the conversations that we're doing right now, that elevating that science into actionable tools really starts becoming important for providing the right benefits from the investments that have gone into our research and the direct value that can emerge out of this work by having this kind of a middle partnership that we are talking here. The collab structure is pretty straightforward. We have a funding that comes in two ways, one from the city, one from the academia, to put in staff and faculty together on projects. There is a integration, so to say, that comes from project management. And then we have a criteria for selecting projects that they are city climate relevant in terms of the extremes or shocks and stresses. They have a direct benefit for the city. And then they have a sponsor of somebody who's excited about this kind of project, will mentor it. And from the city side, from the UT side, and working together, they think that they can create something new that is not available doing individually, this co-production process. So we started with the heat project, the heat mapping. I think Jim also mentioned one of those heat mapping projects that were there, active through NOAA. We had a follow-up to that NOAA project, a substantial grant from NOAA to start looking at heat and health. And that essentially started the notion that, we can do one thing in just doing the measurements, but if you bring in the academia, we can then now take those measurements and create new tools and science. And that's where some of the ideas of collab started taking place. Then after getting some of the initial NOAA funding, we got a pretty substantial digital twin project that was appropriated by our congressman for the collab through NIST on using AI and tools for creating a digital twin that can start looking at the interfaces with regards to their science to decision pathways. Then we had a series of projects which I'll show, and been able to get funding through NASA and other agencies and NSF and a few others. And so it has been a partnership where we are using the core funding, we are using partnerships, and we are going to agencies and pulling all this together. And then we were also recently, as I said, last year, seeing the value of this work. UNESCO awarded a UNESCO chair to see that how this partnership can be taken globally to other places. So the initial projects that we started off, first one was, as I said, the climate projection. Second one is the Austin Digital Twin, the AUDT one, where every building that we have on the public campus, you can see what could be the energy used today, what could be the temperature, what could be the projected use, and whether it makes a priority for a retrofitting or changes in that particular building and so forth. The other one has been a cool payment one, where we are testing. A engineering firm came up with a couple of claims about how much it can cool the city, and the city needed some independent review of that to try to see, because it's a big investment when you're putting miles and miles of cool payment. And also there are multiple cool payments that are possible. There's not just one vendor. And so we have been doing some cool payment pilots by having parts of cities where similar new neighborhoods, one with cool payments and another without cool payments, doing a very well-designed experiment where we are doing measurements and modeling and trying to understand the value of that, how long that impact stays, et cetera, et cetera. Then trying to create a network, because we often find that we are going to the same set of people and asking them the same set of questions because they know how to interact with us. And so how do you broaden that interface has been one of the community network analysis that we have been doing, and developing a climate atlas, essentially trying to find out into what we call a data decision framework, that who needs the data, why do they need the data, what format, when, what accuracy, and how do we know that what we have provided is useful? So if we can create this kind of a pipeline, we find that we are much more than focused in terms of aligning our resources to delivering something which is required and can show a tangible result, rather than creating this big network of data set and then saying, here, use it, which the community, as you know, has not been particularly thrilled having to redo things on their own. The other thing we had been doing was to try to see humans as a sensor project, where we can do remote sensing, we can put low-cost sensors, we can do modeling, but how humans feel heat, how humans feel impact. Is there a match? And if not, why not? And if there is, then it adds value in terms of evaluating. This has been particularly useful because we have been using AI tools to downscale information. And one of the reasons we downscale information is because we don't have data in the first place. And if you don't have a data, the question comes up, how do you evaluate which technique works better? Is it diffusion? Is it just super resolution? Is it good old Kriging? What will work best? And so those kind of things, we are getting some sort of the question about why are you downscaling this data? And is the user actually finding value in that? That is where we have been going back to the community and end users and trying to do this. The other question that had come up was through the Council on the Passive Housing, that should the city change some of its energy requirements to help with the energy costs and so forth. And so there had been some passive project work that has been going on. In 2025, then we started some projects on a forest health mapping, where every tree with the LiDAR data sets that are available for the city, we started developing a neighborhood scale tree data set. And then it's an ongoing project in which first we are doing the mapping, and then the second one we are doing the health of the trees to try and understand which places we can have, because this has implication for fire fuel. This has implication for the post-storm debris collection. It has implications for hydrology and watershed. And so this was really interesting project that we have been doing in trying to map the trees in and around the neighborhood, because there is also a mandate by the city where it wants to grow its tree cover by 50%. So where do we grow? What do we do? So there is an app that has been developed through a NASA project called TreePot, which is a tree planting optimal tool. And that tree pot, you can essentially see where, if you plant that particular set of trees, what is a value that emerges out of that investment into that output. So we have been working with Tree Folks, which is one of our community organization, into part of this. The other one has been a demolition and carbon storage or carbon credit that we can get. So recycle or reuse versus whether we has been one of the question. And so when we have permits coming up for the kind of application with regards to city constantly going through this demolition or modernization, whether we recycle or reuse has been a question. And then how do you see the value associated with that has been another project that has been going on. The other one has been about scenario planning, in which we have been looking at the departments and how prepared they feel they are for developing the future risk assessment. Are they concerned? And if they are concerned, do they have the tools and resources available? And so we're trying to see the mapping that who is concerned and feels they don't have tools versus who thinks they have tools and they are not concerned, et cetera, and then trying to match tools with the concern and trying to match what they need with what they're concerned about with the tools that we may be available, or prioritize the next set of tools that we want to develop. Another project underway is on with both emergency management and Austin Fire Department, that issue about the D2D, the data to decision, where what information, when, why, how, those sort of things have been put together. And then the thermal mapping in terms of having humans provide a context of the data, experiences, and value of the data that we are providing. So some of the lessons that we have learned is that, of course, that we need to build up these partnerships. You can bring the best technology, but if your end user and your community and the stakeholder do not feel comfortable, you can't get that match. It was interesting to see that some of the stakeholders looking at satellite data and saying, that's a great picture, but they never looked at satellite data as data. To them, the data was a sensor sitting on the ground. And so it needed some sort of a coordination of understanding of to how that satellite data is actually a data and not just a pretty picture, and there's value embedded in that, and the picture actually comes from data, etc. So there has been, we might bring technology, but the usability and appreciation of what the user wants had to come through. We had seen that this has emerged as where the departments start looking at academia as collaborators and not just consultants that will be coming and going. We are looking at creating these partnerships not as a funding model, but as a seeding model. And we have seen that this could be transferred to other cities. But so we had been working with cities in Portugal, in France, in Singapore, recently in India and other places where we are trying to see how this model, what they are doing that we can use and what is it that we can do can be of value to them. And UNESCO has been a great coordinator in that regards as part of the chair. So, and of course, it has been a good situation to be in where this kind of a partnership could be leveraged to bring in federal support. Clearly, there has also been a great positivity in terms of the students wanting to work with the city, students wanting to work in this domain, and not just look at climate as a global climate modeling problem, but in a very applied sense that you can be excited about data, you can be excited about tools, about the AI use, and you don't necessarily have to leave the domain to start being in that AI domain that people want to be. And so finding that match has been another big aspect of what we have been seeing in terms of creating that human resource pipeline going forward. This year, we have a few more projects going on. I'll not go through all of them, but including a city inundation risk mapper. I, in fact, just sent an email to Jared saying that I would love to have a follow-up meeting. There's another one about indoor versus outdoor heat. A lot of measurements we have as for the outside temperature, how people are inside. We had done a study with a group in Sydney, and what they stated stuck onto me, that a person living in a poorly constructed housing is more vulnerable than a homeless person out on the street during a heat wave. And so we don't necessarily understand that or communicate that enough. And so how can we then look at housing to be done from heat wave perspective in a different way as we have been doing for floods is something we have been trying to now start understand. Continuing work with the cool payments, but there's a very fascinating aspect of cool payments that it could probably have some ecological impacts with regards to the titanium or some other coating that has been used. And so we want to do the water quality part of that. Continued work with the risks and the demolition, reuse or recycle perspective, and then the issue of recycling that is embedded in the building energy models and so forth. And the core of it is the data to decision tool modeling that we are trying to work. So I'll close by saying that these collaborations are fun because you can necessarily see, just like in agriculture sometimes, that you have a start of a season, you tried certain things, and at the end of the season the ag community can tell you and say that the yield was good, we could benefit from it. There have been a very finite 1 year activities, and we can see what we're doing is helping or not helping. And this has been really one of the way that we think by this co-production process where everyone is engaged, we start doing that. So I'll stop there, and thank you very much, Doug, for pulling the session together. It has been enjoyable. Thank you.
Excellent depth. Thanks. I think that's a great. I think if we can have Jim and also Jared back on camera, that would be great. I'm also very jealous when I first learned about the collab model between UT Austin and the city of Austin. And I think one time, Dev, you mentioned that you're borrowing the state climatologist of model to have a state climatologist for the city of Austin. I think that's an interesting way to think about those university and the city collaboration partnerships. And I think now we have time for the questions for discussion with all the three speakers. And I'm going to kick off with the first question I think I warned you about, which is with the winter storm coming, are you working with any of your specific audiences or partnerships that you have to get people ready, either through public engagement or maybe more detailed providing information to support them? Jared, I know we talked briefly earlier. I know you are more on the public side. So, Jared, do you want to start?
Yeah, sure. So with this winter storm, I mean, our mission is to look at the climate, right? And so what we're preparing for is basically we're already preparing past winter events and kind of like compiling what do we know, what knowledge, how historic will this event fit within the context of previous events. And so typically one thing that our office does, and Corey Davis, and Dev probably knows Corey that works with our office, he writes really good blog posts, and they get lots of exposure. And so typically what happen after a significant event is, and this is something we're preparing to do, is we'll have a rapid reaction to that event, and we'll talk about how significant it was, what actually happened, and then that's can then inform the public, but also the state agencies and things like that, and the local partners. So we're kind of a little bit on the back side of things at most of the time, I'd say, Douglas, instead of the front side, which I heard from Jim, and he can talk about his stuff because they're the ones that really are taking action. We're kind of on the other side of the equation.
Thanks, Jared. I just put a link to the climate blog from CITAM office, which have awesome resources. And I know I'm on the mailing list. And so every time when they send out a new posting, that I always try to share with others as well. Jim, do you want to go next?
Yeah, I have a cool story. Before joining the city of Raleigh, I was with the city of Boston, and I actually had to answer calls from citizens during blizzard events. And so it's this interesting expectations on the citizen side, right? So people would call and say, hey, I don't see a plow on my road is impassable, etc. And they had an expectation that I was going to hang up the phone, grab my jacket and my hard hat, jump in a truck, and go and plow their street for them, which, to be completely honest, I don't think is unreasonable expectation, right? It is, hey, I am reporting an issue. I don't see you, dealing with this issue. So one of the things that I'm in charge of in the city of Raleigh is to try and give people visual awareness in what's going on in the city. Yes, you are experiencing this event that's happening, this ice event, and a tree has fallen over the road. We want to know about that. But I also want to share with you that 400 other people have reported that trees are down. And we have 64 crews out right now and where they are. And we're making progress. And that call that your tree down is very important to us, but it's not the only tree that's down. And there's the city is working for you. And so I think as in the data field, my job is to create situational awareness for internal staff. So, right, for operational folks in leadership, where are people? What are they doing? What's next? How do we prioritize those things? But also on the storytelling side to say, hey, your city is working for you and they are doing the best they can given the resources they have to respond to this event. So I don't know if that answers your question.
Yeah, thanks, Jen. That's a very good story. Yeah, that reminds me during Hurricane Helene that the city of Asheville has been doing daily briefings about where they are at, trying to repair the water systems and to connect to make sure that people are aware where the progress is. I think that's a really important step to communicate with the citizens. Dev?
I echo what Jim and Jared mentioned, that I think one of the key aspects when you're in the middle is to respect and understand who does what best and support them. In this particular scenario, when there is an emergency response and when there is a need for a single line of communication, we completely stay in the background. We are in communication if there is a question. I'll give an example. We had the hurricane that made landfall, the name escapes me for some reason last year. And this was actually coming towards Austin. And the track was towards Austin last year. And the we were testing an AI-based model at that point, and it was showing the track was moving much more east. Now, we did not want to just put it up on the news site and say this is what it is, but what we did do was connect with one of our partner and say that our models that we are using are showing that there is that there's a potential this will actually go Houstonwards, and this was 4 days ahead of time than what the physics-based model started showing. So somewhere in their mind, they were aware of this, and when they started seeing that signature, they could communicate, and then there was a little bit of a plan that this could be not an event for Austin, but moving towards Houston. Now, that was probably serendipity, it was a chance, but the point is an example that we will not go up front and say this is what we're doing, but we will support. That's number one. Number two, we don't dig wells when there is a drought right away. We start planning where we can dig wells when we are out of that emergency. And in that scenario, we are trying to understand what was it that they were really trying to look for, and just making sure the students and the research is aware. And so it starts becoming a research tool going forward. That's two things we have been doing: respecting boundary, available as a tech support, and number three, learning from what they tell us to do future plans.
Great. Thanks, Dev. I want to open it up to anyone in the audience who have questions for any of the speakers or just general question. You can either put it in the chat or you can just raise your hand and ask the questions. Don't be shy.
While we are waiting for others, okay, go ahead.
Well, yeah, we do have. Yeah.
Oh, sorry, I didn't mean to interrupt. But I had a question for you, Dev. I'm really impressed with the structure of the collab and how you've engaged with local governments. I was just curious to learn more about kind of how, what motivation had to exist from both sides to kind of make that happen. I think, here in Honolulu, there's definitely kind of like a piecemeal of different academic groups working with different city and state agencies, but there's definitely not really this level of coordination or I'd say efficiency in those projects. And so I'm just curious to kind of understand like how, if you could speak about like where the motivation came from and kind of what needs to be in place to structure something successful like that.
Yeah, I think all through my academic career, I had been a state climatologist or associated with the state climate office, North Carolina, then Indiana. And then after I came to UT in middle of pandemic, this was the first time I was not associated with the state climate office. But I also realized that coming to cities, the products and tools that have been generated by Climate Office, traditionally, because of the nature of the history of the Climate Office, it's for ag-related, water-related, and of course, we have moved on, but that has been the legacy. And so cities, as I mentioned, have unique needs, and this became a bit acute after the 2021 ice storm, where the city really recognized that there is a need for having a local scale understanding, coordination, and resilience that build up. That planning was going on, and lo and behold, we had the 2022 ice storm. And so that just solidified that we can't take these events as once in a lifetime event. They happen twice in a year now. And so there was a recognition, but what the ingredients we needed was, if there was serendipity is always a thing, but I think the first one was we needed some support from the academia, where there was endowments or some funding available. We had a lawmaker who was very passionate about it, could take and understand what we're trying to do. We had someone from the city who had experience working with academia, and then that could take down both from the administrative end of the city and the public-facing end of the city, and then do the same thing with academia to try to say that this is value. And so once that happened, I think people could, it was a very strong business case that needed to be done, and with a tangible output and ROIs and so forth. And I think people could see that there was a value, and there's a lot of serendipity for this kind of things. You have to just keep trying is how I will say it. I mean, what I learned in North Carolina, when we started EcoNet at that point, or it was called AgNet, that has become like a model for Mesonets later on. I think I learned a lot of things with working with this fantastic group of people and just passing it along.
Thanks, Dev. we have a question in the chat from Christine. I think it's for everyone. And what are the biggest barriers for state and local governments to use federal data? Is it finding applicable data set? Is it usability of the data? Is it resolution, for example, temporal or geographic of the data? Is a lack of familiarity with those remote sensing data? And Christine is based at NASA. So Jim, I saw you're muted. Can you start?
Yeah, sure. So yeah, this is a great question. So there's a couple of things. One is I feel like in all levels of government and local government specifically, we are massively understaffed. And so we are heads down trying to do tactical work. And sometimes we forget to lift our heads up and look around a little bit. So awareness. One is awareness. Do we have good awareness that this gap in our data exists at a federal level? So that's one. It's just like, how do we know all of the data? And then the second one is, in our specific case, sometimes we run into the resolution piece, which is because we're trying to integrate local data, which we have at a super hyper high resolution with other data sets. Sometimes we have to up whatever the right word is to aggregate this data, that we then lose some value out of the data once we do that. So I had mentioned that we were doing the community condition model. So we're doing that at the block group level, because that was the lowest resolution we could get for some of these federal data sets. But we have point-based data for a number of other things that are participating in that model. So that's the second one. And then third is something that is less of an issue, which is just how do we integrate? We want to try and like the technical plumbing around integrating it. I would say the data sets are much more available since data.gov and APIs and all that sort of stuff. But that has been sometimes that is an issue.
Thanks, Jim. Jared and Dev, anything you want to add what Jim have mentioned? Since I know both of you have played intermediator between the agencies and the data or the tools that's available.
Yeah, it's hard when you're a center like us to talk exactly what the local people are using and the things, because I'm not on that end exactly. But from my experience, and I've only been with the State Climate Office since, even though Dev he has a lot more experience in this world than I do. But my experience is a lot of times is how much staffing people have, as Jim mentioned. That's something that I've always found interesting, is that no matter what, and that varies, right, from city to city. And I think that's a big challenge, I think, at the local level, is the capacity. And so if I were to say something that's a big problem, a big challenge from my experiences, it's capacity, but it's also, in my experiences, communicating things that we know very effectively. And so one thing that I've tried to do in particular is to go outside of my area of expertise and hit those communities. And so I've attended, for instance, engineering conferences, and I've gave presentations. People you'll be surprised. They're like, oh, we're so happy to have a climate scientist or an atmospheric scientist here. So we have lots of questions. And then they start thinking, and then they're saying, oh, I didn't realize that existed, right? And I think it's just that communication and being able to make sure that we get outside of our box and that we're comfortable in. And if we can do so, I think it'll be very rewarding in the long term. And that's something that I've found is going outside of my sandbox and dabbling in other things. And so I know, Dev, in the city thing that you're doing there, that's exactly what you're doing. You're an atmospheric scientist, but all the things that you're looking at, you're going across disciplines and things like that requires a lot of expertise. So,
Thanks, Chair. Dev?
I'll just say, I mean, this is a great question, Christine. Um, See, even from the core meteorology community, this debate has come up. Is model output data, is reanalysis data, or is a co-op observation data? So it is not like this is a question that has not been addressed. What is data is always a very semantic and event and uh, uh, it has a purpose-driven question. That is one. Now, when you come from the context of an end user who is not within our domain, to them, they had been looking at data as numbers. And so when you say an image, it does not translate directly that an image is actually numbers. And that translation is where one of the things that needs to be communicated. Third aspect is that we have a lot of projects and programs which go from 0 to 1, that here's what you have and here's adding the value. But a lot of these users need -1 to 0, meaning, tell me, even when you say here's a code you can use, they're like, what's a code? And when you say use meaning what? So that's where it goes into the context of the D2D, the data to decision framework, that even if the unit is wrong, even if the resolution is wrong, even if the format is wrong, they are not going to find it of value because they do not want to do that extra piece of work. You customize it, deliver it, make it available, it'll work. I used to say, it's not like the Blockbuster video model. We went to Netflix, and I found it was a younger crowd who had never been to Blockbuster videos. So I'll say we don't need a Walmart warehouse model. We need an Amazon model. Go online. This is what I need. Get it. You're happy. End of story. And I think that's where we need to do with our delivery right now with data.
Thanks, Steph. Christine, I saw you on camera. Do you have anything you want to follow up or?
Not at all. I was just curious. Thank you. Especially with that last one, it sounds like, to a certain extent, a lack of sort of technical capacity. I mean, obviously, sort of, I'm hearing lack of capacity overall, but specifically a lack of on the data science coding end of things. If I'm understanding that, in addition to the larger lack of capacity in general.
If I may quickly add,
go ahead, yeah.
It's like with the advent, in fact, to counter technology, we need technology. Or counter the lack of technology, we need technology. And that's where LLMs and some other things, where there are these chats coming up. Like, you don't have to be very specific about, I need data for dew point of in Raleigh. You can actually put the problem almost like how you talk to a state climatologist or a person, and if the data that can come out. And I know there are several such apps that are coming up now. People are working on them. So within a year, I expect this problem not to be a major problem. But what still gets developed for it to be, what I say, not just useful, but usable, I do think we need to have the human interface part of it. So that's where I will go on this.
Thanks, Steph. Yeah, I think going back to, Christine. I think going back to the lack of staff capacity, earlier last year, we had some interaction with the North Carolina Forest Services during after Helene, the concern of the fire risk in the western part of North Carolina. And they literally just told us, right now, we don't really have any staff. We can create those maps of the risks because the staff had left, or because the people who can do the GIS mapping for them has left. So there's an urgent need for the staffing for many local and state agencies to support a lot of data analysis and for decision making. Carla, I know you unmuted yourself and also put a question in the chat. Carla, go ahead.
Yes. So two things. I just wanted to quickly comment on this issue of data. So in my education presentation the other day, I did start out with what is data. And the first thing is numbers, but we have images, even sound. So I think in reference to what the last commenter said about data science education, that infusing that into the K-12 space is one way that helps all of us. I've been working with teachers and students for years to help them go outside, collect data, and then use LiDAR data or other satellite data to ground truth, what they're doing on the ground and comparing it. But we always run into these same issues of scale. So anyway, that was to address this idea of the importance of the public at large, but also young students just understanding data is more than numbers. Second, I was really curious as to whether in Raleigh or in Austin, you have connected with the middle and high schoolers, maybe that might be collecting citizen science data, such as through the Globe Observer app. I thought I heard one of the presenters mention a different tree app from NASA, and I don't know if it's different from the other one, but just curious about whether there's any of that connection for the small scale data that you want to collect.
I'm happy to start. So Carla, to be honest, not nearly enough. Not nearly enough collaboration with citizen scientists, whether it be through primary or secondary education. We've sort of dipped our toe in. We have some examples. The NOAA project around heat detection included some citizen volunteers, and we have a couple of other little tactical projects that we've kind of spearheaded within the city, but haven't plugged into those big ones that you were talking about. I think of like the iNaturalist stuff or other big, large projects that are just a treasure trove of valuable data. So I don't have great examples of that.
Ev, do you have any examples from the city of Austin about citizen science projects and engaging with primary and secondary educational institutions?
Yeah, I mean, the human as sensor, so to say, has been one aspect where we are using the impact people feel as one. Specific to the globe, while I'd been involved in this earlier on when we were doing climate education, current environment has not been necessarily aligned that we could take that as a priority project to work with, but we are certainly very interested in trying to look at the integration of art and citizen science to communicate, because whether it is a data and so forth and educate resiliency. So we are certainly very interested, and if there are avenues and opportunities, I would love to follow through with Carla.
Right.
Well, maybe I can talk with you in Austin this summer.
Thank you. Any other questions for any of the speakers before we wrap up our session? Yes. Althea?
Althea, yeah. Hi.
Yes, go ahead.
Thanks. I live in a fairly small town, about 20,000 people, South Lake Tahoe, California. It's an interesting regulatory landscape. We've got federal government, state government, county government, city, with a lot of nonprofit and state conservation agencies, all operating in a very small space. We deal with wildfire and drought. And as I've been tuning more and more into the city government, there does seem to be a lack of capacity for answering some of these or just working together. And I guess I'm curious. I work remotely. I'm a data scientist. I think there's a community of other data and tech people in the community that are not tapped into our local government and not supporting and engaging that. I'm just curious if there's a opportunity or examples for sort of an open source development to perhaps help with some of the capacity issues with community members that are highly educated and fluent in data. And I'm just listening to these different perspectives and scaling data and how we can address the capacity with maybe an open source project.
Thanks, Althea. Jim, I think everyone
happy to
wants to
kind of
jump
share
in.
share my experience and some of the opportunities and potential challenges. So there are in Raleigh, we're lucky enough to have a very active civic tech group that exactly like, hey, we're really knowledgeable. We have a tech economy in the city. We'd love to roll up our sleeves and help. And so there are like things like Code for America that have these little brigades that allow you to do potential projects. So that's on the opportunity side. On the challenges side, I have a slide in another deck someplace that is like the problem that one of the challenges is that those folks they're invested because they're civic minded now. And so there's not a sustainability kind of built into that. Really quick, when I first got to Raleigh, this local government, this local civic organization had built a tool to do bus stop repairs. You could kind of adopt a bus stop and you could fix it. And my first day, the citizens started calling me because it was broken. And there was nobody to call, and there was nobody to like, and there was skin in the game. And then when you were like, hey, can we put together this kind of MOU? They're like, well, whoa, we're just trying to help you. We don't want to create a contract. So there's just it's not in my opinion, it makes complete sense, but sometimes there's a little bit of complexity there.
Thanks, Jim. Jared?
Yeah, so I think the North Carolina has something called the North Carolina Flooding Blueprint that the state agency is trying to help communities think about flooding. You could think about this being, any risk that you might think about, wildfires or whatever. But I think what they're trying to do is this train the trainer, right? And so they have these regional councils within North Carolina, these nonprofits, and then basically they go out to the communities and they may not know how to use this tool, and it takes some training to learn how to use this, flashy new thing that's out there. But the idea is that DEQ, which is leading it, would then train these regional councils that then go out to the communities, and basically it's like a train to trainer model. So then it's kind of filters down. And then people feel comfortable and have points of contact for questions as it goes. So I think that's a good philosophy of how, you get, I don't know about, whatever open source we're talking about here in terms of things, but I think this model is something I'm interested to see how it all work out in the long run. But I think it's a good attempt at trying to think about, those with the less capacity. How do you train them to be more skilled in certain things that are available out there? So,
thanks, Josh. Can you just do a quick question since we need to wrap up?
Yeah, I didn't. We don't need to belabor. I just wanted to reinforce Carla's point in that I work for a small private company, but we're not necessarily looking for billable hours. We are very open source focused, and I maintain myself probably a half dozen kind of dashboards and tools that take almost all of them tap into NOAA, NASA, and other large federal data, and they provide kind of insights analysis that we use in-house or we use to guide our stuff. And we're always thinking these must be helpful to some level. Most of these use census data so that you can analyze these large climate data sets at the block level or the statistical metropolitan area level. And our issue is just kind of hooking up with stakeholders and what are best ways to kind of get in contact with these people, because I don't want to build them hours. I want to onboard as a stakeholder, and then together we go to NOAA or we compete for federal grants where I have a stakeholder on board and I say, I have an existing partially kind of some level of polished tool, and we want to adapt it to really help these people out and help this municipality make, informed decisions and keep it open and continue this on. So we work with the state climatologist at Vermont a lot, but unless it's kind of a happenstance relationship, not being part of a large local university, we can struggle to find the local municipalities and what are the best ways to, outside of just I want to just cold email or walk in someone's office. But so building on Carla's, we have the technical capacity, we have tools and various things and partial. What's the best way to get together with some of these types of organizations?
I guess, Jim, I'm going to point to you and maybe Dev, just a quick response, like if people want to help,
yeah, sorry.
how can they reach
you
out
don't
to
have,
us?
You don't have to respond. I just wanted to reinforce her point that we're out here and we can help. We just sometimes need the best way to get in touch with you all.
Yeah. Email, phone call. Yeah.
Okay.
Love to connect anytime.
Yeah, I would say the same thing, that we probably need through ESIP and other platforms a collation of such things. But in closing, I'll just say one thing that comes across, Doug. You talked about staffing and other factors. I think there is sometimes a perception in the broader community that climate is not pro-economy. I think what you see from these kind of sessions is climate, especially in the applied climate, is critical for the economy. And that aspect where we need more support to build our economy to be stronger by having this kind of an applied climatic aspect, whether it's for ag, water, cities, and other applications, this is really important. And I hope that message can be conveyed from ESIP and others to look at it.
Thanks, Steph. And we're ending with Steph's comment because we are actually going to City of Austin for our July meeting. So hopefully we'll have really strong connection and collaboration with City of Austin in July and for our July meeting. So thank you everyone for the session today. And thanks to all the speakers for joining us in spite of the looming winter storm this weekend. So hopefully everyone can stay warm and safe. And thank you everyone, and see you all in the future.